In this tutorial, we shall look into an important topic which is about second derivative of a function. Before now, you already know that whenever you have a function, let's assume y equal to 3x raised to the power of 2, and you are asked to differentiate this function or to find the derivative of this function, what you will say is differentiating y with respect to x will be equal to multiplying the term 3x squared, multiplying it by the original power of x, which is 2, then subtracting 1 from the original power of x. And that will be equal to 2 multiplied by 3, we have 6, then x raised to the power of 2 minus 1 will give us 1. And solving further, 6x raised to the power of 1 can still be put as 6x, because any variable raised to the power of 1 is still that variable. So automatically, the y dx, that is the derivative of this given function, is 6x. That is very simple. But this is what we basically call the first derivative of a function. So the dy dx here is just the first derivative of this given function. But remember that differentiation can be repeated on a given function as many times as required. That means after we must have found the first derivative of this given function, there is still possibility of us to find the second derivative of this given function. Okay, let's go ahead to solve the questions we have here. You will get to understand better. The first example says, if y is equal to 3x raised to the power of 2 minus 2x squared plus 4, we are then asked to find the squared y all over the x squared. So the squared y all over the x squared here simply means the second derivative of this given function. Remember, the first derivative is the y dx, but the second derivative is denoted as the squared y all over the x squared. This is what we call the second derivative of a given function. Okay, let's go ahead to do that here. Solution. The first one, we have that y is equal to 3x squared minus 2x squared plus 4. First thing first, we shall differentiate this function the first time, then after which we differentiate whatever we get at the first differentiation the second time. So let's differentiate this function the first time. We have dy dx, that is differentiating y with respect to x, and that is equal to, here we have 2 multiplied by 3x raised to the power of 2 minus 1. Then minus, we also have here 2 multiplied by 2x raised to the power of 2 minus 1. Then plus 0. Don't forget that when you differentiate a constant, you simply have 0. Okay? Then we have that 2 multiplied by 3 will give us 6. Then we have x raised to the power of 2 minus 1 is 1. But any number raised to the power of 1 is still that number, so we remove the 1. Then minus 2 multiplied by 2 will give us 4. Then we have x raised to the power of 2 minus 1 is still 1. But a variable raised to the power of 1 is still the variable, so we remove the 1. Then plus 0. So adding 0 to everything we have here will still give us the values we have here, okay? Such that our dy dx is equal to 6x minus 4x. So this is the first derivative, but we are asked to find the second derivative, which is the squared y all over the x squared. So that means we shall differentiate this given product we have here the second time. So we then have the squared y all over the x squared. That means differentiating the product we have here the second time. Then we have 6x raised to the invisible one, which we know initially was here. Then we subtract 1 from it. Then minus, we have here 4x raised to the invisible one we had here initially. Okay. then minus 1. Then solving further, we have that the squared y all over the x squared is then equal to 6x raised to the power of 1 minus 1 will give us 0. Okay? Minus, we have 4x raised to the power of 1 minus 1 will still give us 0. Such that the second derivative of this given function, solving further here, we have 6 multiplied by any number raised to the power of 0 is 1. That is one of the basic law of indices. Don't forget that. Minus 4 in brackets. Any number raised to the power of 0 is still 1. That is one of the basic law of indices. Such that the squared y all over the x squared is then equal to 6 multiplied by 1 will still give us 6, minus 4 multiplied by 1 will still give us 4. Such that we solving further, we have that the squared y all over the x squared is then equal to 6 minus 4 will simply give us 2. That means that the second derivative of this given function is equal to 2. Let's go ahead to solve the second question we have, which is question number 2. Let me clean here for convenience. So question number 2, we have that we are asked to find the squared y over the x squared of x plus 3. That is very simple. Let's first of all make this a function by saying that y is equal to x plus 3. Okay? Such that differentiating y with respect to x is equal to, here we have x raised to the invisible 1, then minus 1, okay, plus differentiating a constant will simply give us 0. Hence, we have that the y, the x, is equal to x raised to the power of 1 minus 1 will simply give us 0, then plus 0, okay? And that is equal to any number raised to the power of 0 is 1. That is one of the basic law of indices. So we have that our dy, the x, is equal to 1. But we are asked to find the second derivative of this function, not the first derivative. That means we must differentiate this function the second time, such that we have the squared y all over the x squared is simply equal to, here we have, remember that whenever you have only a constant 1, differentiating it will simply give us 0. I hope you know how we got it. 1 is the same thing as saying 1x raised to the power of 0. Because 1x raised to the power of 0 is the same thing as saying 1 multiplied by x raised to the power of 0 will still give you 1. And 1 multiplied by 1 is 1. That means 1 is the same thing as 1x raised to the power of 0. Such that when we differentiate 1x raised to the power of 0, we shall have that this 0 will multiply the 1, then x raised to the power of the 0 we have here, then we subtract 1 from it. And that will be equal to 0 multiplying everything we have here will still give us 0. Okay, that is how we got the 0 we have here. So differentiating a constant is simply 0. If you don't want to take the stress of solving further here, just know that differentiating a constant is simply 0. So this simply shows you that it's possible to differentiate a given function as many times as possible. It's not only differentiating it on the second instance, which is the squared y over the x squared. You could as well differentiate a given function any multiple times as much as possible as you are required to do. Thank you for viewing. Thank you for watching. If you found this video useful, remember to reshare this video. Remember as well to subscribe to my YouTube channel and as well to follow me on Facebook. Thank you and see you next time. Goodbye.